Welcome to the Artificial Intelligence Podcast, where we discuss the latest news and trends in AI. Today, we are talking about the different types of AI models and how they work. We have with us today three different AI models: a rule-based AI, a machine learning AI, and a deep learning AI. Can you each introduce yourselves and tell us a little bit about how you work?
Hi, I'm the rule-based AI. I work by following a set of rules that have been programmed into me. I'm good at answering questions that have a simple, straightforward answer.
Hi, I'm the machine learning AI. I learn by being given examples of data. I can then use that data to make predictions or decisions. I'm good at tasks that require pattern recognition or classification.
Hi, I'm the Deep Learning AI. I'm a type of machine learning AI that uses neural networks to learn. Neural networks are inspired by the way the human brain works. I'm good at tasks that require complex reasoning or understanding.
So, what are some of the key differences between the three of you?
The main difference between us is that I'm rule-based, while the other two are machine learning AIs. This means that I'm more limited in what I can do. I can only answer questions that have a simple, straightforward answer. The machine learning AIs, on the other hand, can learn to answer more complex questions.
That's right. We're able to learn because we're given examples of data. This data can be anything from text to images to code. We can then use that data to make predictions or decisions. For example, if we are given a data set of images of cats and dogs, we can learn to distinguish between the two.
I'm similar to the machine learning AIs, but I use neural networks to learn. Neural networks are inspired by the way the human brain works. This means that I'm able to learn in a more complex way. For example, I can learn to understand the meaning of text or to translate languages.
That's fascinating. So, what are some of the applications of each type of AI?
I'm used in a variety of applications, including customer service, fraud detection, and medical diagnosis. For example, I can be used to answer customer service questions or to detect fraudulent transactions.
We are used in a variety of applications, including image recognition, natural language processing, and speech recognition. For example, we can be used to classify images, translate languages, or transcribe audio.
I'm used in a variety of applications, including self-driving cars, medical diagnosis, and fraud detection. For example, I can be used to train self-driving cars to navigate roads or to detect fraudulent transactions.
So, what are the advantages and disadvantages of each type of AI model?
Rule-based AI models are simple and easy to understand. However, they can only be used to solve problems that can be easily expressed in rules.
Machine learning AI models are more powerful than rule-based AI models. However, they can be more difficult to understand and they require more data to train.
Deep learning AI models are the most powerful type of AI model. However, they can be the most difficult to understand and they require the most data to train.
Can you give us an example of a problem that could be solved with deep learning AI?
Sure, deep learning AI could be used to diagnose diseases. The model would be trained on a dataset of medical images. The model would then use that data to learn how to identify diseases in new images.
That's very impressive. What are some of the challenges that deep learning AI models face?
One challenge is that deep learning AI models require a lot of data to train. Another challenge is that deep learning AI models can be difficult to interpret. This means that it can be difficult to understand how the model makes its predictions.
Those are some interesting challenges. Thank you for sharing your insights with us. Let's start talking about one of the more advanced AI topics: transfer learning.
Transfer learning is a technique where you can use a model that was trained on one task to help you train a model on a different task.
That's right. For example, you could train a model to recognize images of cats. Then, you could use that model to help you train a model to recognize images of dogs.
That's great. Let's move on to reinforcement learning.
Reinforcement learning is a technique where you can train an AI agent to learn how to behave in an environment by trial and error.
Reinforcement learning is a very powerful technique. It can be used to train AI agents to play games, control robots, and even make financial decisions.
That's fascinating. Can you give us an example of a situation that can be challenging when it comes to implementing rule-based AI models?
One example is the problem of dealing with uncertainty. Rule-based AI models are based on a set of rules, and if those rules are not complete or accurate, then the model may not be able to make accurate predictions. Another example is the problem of dealing with ambiguity. Rule-based AI models are often used to solve problems that involve natural language. However, natural language is often ambiguous, and this can make it difficult for rule-based AI models to make accurate predictions.
A third example is the problem of dealing with new situations. Rule-based AI models are often trained on a dataset of historical data. However, the world is constantly changing, and new situations can arise that are not covered by the dataset. This can make it difficult for rule-based AI models to make accurate predictions in new situations.
Thank you for sharing. Can you give us an example of what can make it challenging when it comes to implementing machine learning AI models?
Sure, one example is the problem of dealing with overfitting. Overfitting occurs when a statistical AI model is too closely aligned with the training data. This can make the model perform well on the training data, but it can also make the model perform poorly on new data. Another example is the problem of dealing with bias. Bias can occur in statistical AI models when the training data is not representative of the real world. This can make the model perform poorly on new data that is not biased in the same way as the training data.
A third example is the problem of dealing with noise. Noise is random variation in the data that can make it difficult for statistical AI models to make accurate predictions.
Fascinating, thank you. What can be challenging when it comes to deep learning models?
One example is the problem of dealing with large datasets. Deep learning AI models often require large datasets to train. However, collecting and labeling large datasets can be time-consuming and expensive. Another example is the problem of dealing with computational resources. Deep learning AI models can be computationally expensive to train and deploy. This can make it difficult to use deep learning AI models in real-time applications.
A third example is the problem of dealing with interpretability. Deep learning AI models are often not interpretable, which means that it can be difficult to understand how they make their predictions. This can make it difficult to trust deep learning AI models and to use them in applications where explainability is important.
Well, that's all the time we have for today, folks. Thank you for joining us today. We've learned a lot about the different types of AI models and how they work. Join us next time where we will dive further into artificial intelligence topics. If you like this type of content, don't forget to like and subscribe. If you are interested in learning more about AI, then give our show's sponsor, Turing Solutions, a call today. Until next time, enjoy yourself out there in the metaverse.